Hello, talking about standard deviation. So this equation that we see right here is standard deviation. And some people say, well, what is that? It looks like a crazy equation. And honestly, it's not that fun to calculate by hand either. So often we use whether it's a graphing calculator or a website to calculate it for us. We use a lot of technology to do this for us. What will show up on the test is, what is standard deviation? What is it? What is standard deviation even talking about? And so this particular equation adds a lot of things up. This particular symbol right here means add up all of the differences from the mean and then square them, and then divide by the number of items in that sample is what we call it, or for example, if the number of kids in our classroom that have a certain height, and if you measured everybody's height in our classroom and then put it on, say, all these numbers on a spreadsheet or something like that, you would calculate how spread out are the numbers. It's another way of saying, what is the variance? How varied are the heights in this classroom? So that's one thing to kind of think about. Well, check out this particular graphic. Number of books read. So this is called a dot plot. And we will be exploring how to make these and some more features that are really important about a dot plot. But let's look at this real quick. We want to know something about the average. Often we want to know the average number of books read per month, and we also want to know maybe some information like how spread out is it. Not the range. Remember, the range was the top number, 9, minus the bottom number, 0. So the range on this is all the way from 0 on the low end to the 9 on the upper end. But we want to know, how spread out are the numbers? Does the spread look more like this, where it has kind of a random weird curve to it? Or often things like SAT scores would have what we call a standard deviation amount of variance on it, like this. This is our bell curve. This is what we call a normal distribution, which means not a lot of people get a perfect score on the SAT, and not very many people get a terrible score on the SAT, but there are a lot of people that fall in that middle range, and so right in there in the middle. This one's kind of more interesting. It's got peaks and valleys, and it's got a little more spread out. And so our data set, we always want to decide, how deviated is it from the average? How spread out is it? So here would be our average. We're going to call that X bar in the middle. And ours in this one would be somewhere probably in that ballpark of an average, and that would be X bar. And our ultimate goal is to decide for a deviation, how spread out above and below are all of the individual data points from that mean or the average. On average, how spread out are the numbers from the average, which is kind of weird, but that's called standard deviation. Let's look at one problem. You're not going to be asked to calculate this by hand, but just know what is standard deviation and what does that number tell us? If it has a standard deviation of 0, that means that they are not spread out from the average at all. All of the numbers are exactly the average or the mean. That doesn't happen very often. But if it has a small standard deviation, then that means it looks more like this with not a lot of variance, all right? Or maybe even closer, like a bell curve that looks like that even, just like all the way clumped together, all the data. That means that you have, say, number of people reading books, they all read the same amount of books, approximately. That's not very interesting data, but if they're really spread out, like this actually has a lot of spread out range to it here. So my standard deviation here would be large. And why would that number of my standard deviation be large? Because the data points are varied quite a bit. They're very spread out from the average. And that tells us a lot of information. Okay, so let's go ahead and look at an example. Let's get rid of that. And I'm just going to walk through it really quickly. Okay, here's our example. In order to go further, here are all of our data points. So these are those are all of the different points that we're going to use. 20, 29, 19, I don't know. Maybe this is the points that students got on their test. Who knows what this is, right? I don't even know. It doesn't say. So let's go ahead and take a look. If I was to calculate the average, I would have to add them all up, and I'd get 300. And then there's 12 data points, so I divide by 12, add them all up, divide by 12, and I get 25. That's my average. That's my mean. Okay, that's the first step in calculating the standard deviation. The next step is to use our equation that we described right over here. Let me see, where's my map? There we go. So right here, what I'm doing is now I'm going to take and find the difference. So I do this part first, then I do this part, kind of like order of operations. I got to go inside of the equation first. Then I'm going to square each one of them separately. Then I'm going to, this symbol means add them up. This is called summation, is what that is. Summing them all together. Add every single data point calculation, then divide by the total. In my case, it was 12. All right? So let's go back to my calculation that I'm working with here. And let's look at the next step. The next step is to find this subtraction right there. Okay? So I take all of those and I do every single, that's why a table of values is very important when you're calculating standard deviation, and that's why we don't like doing it by hand. Instead, we do it in a calculator, and there's online websites that'll just do it for you, and I allow that. In class even, if I ask you ever to calculate standard deviation, I just let you use a graphing calculator, we'll do it for you, or a website. And so there's a website right up here that I'll show you in just a sec. So then you subtract it and you square each one. All you did was take that value and square it. Take that value and square it. Remember, a negative times a negative is a positive. And so let's go ahead and just keep going through this list. Now what am I going to do? Now I'm going to add them all together. Just like it said summation. The summation means you're going to add them all together. And I get 212. 212 divided by 12 is going to be 17.7. Not done yet. Almost. Now, after I divided by 12, because this n value right here, n represents how many data points there are. Right here, for example, there are 12 data points. Okay, so now that I have 17.7, the very last step is to square root it. Okay, so I'm going to take this, leave it in my calculator, and square root it, and I finally end up with 4.2. What does that mean? Now, more important than calculating it, because this takes forever and it's time consuming and we really aren't going to do a lot of this. But what does that number mean, and how can we interpret 4.2? It just means that if this is my test scores and the average is here, like say I've got a bell curve a little bit, and here's my average, and remember my average in this case was 25. So the average variation from 25, from the score of 25, is 4.2 points. If we're talking tests, it would be points above and points below. All right. This is a very important calculation, especially when it comes to like statistics in sports or statistics in surveys and polls and things like that. This tells us how closely related are all of the data points. For example, baseball is full of statistics. And if you have a batting average or something like that, you kind of want to know how consistent are you with your, I don't even know baseball very well. Anyway, but or test scores. How consistent are all of your test scores, or how close together related are all of my students on their test scores, that kind of thing. And so this says that it's on average 4 above and 4 below. Really 4.2, but 4 above and 4 below is the average variation from the mean. All right. So that concludes our talk on standard deviation. And if you have any further questions, let me know.